This video is about homework number 1. First I'm going to talk about question 1, just a little bit. This was the one that had 10 statements, all of which had something wrong with them, and I asked you to mark it as if you were marking someone else's homework. And this was mostly very nicely done, and I liked the comments that people wrote on the work. I'd just like to say one or two things about one or two of the questions. There was more than one involving the binomial theorem. So the number 3 of this involved a minus b cubed. Now, quite a lot of people in exams work this out very slowly by saying, well, this is a minus b times a minus b times a minus b, and so on. But I wish that you'd be able to use the binomial theorem on this immediately without having to go through the process of multiplying out the brackets. You should be able to write down what this is immediately. And it's very easy. It's like this. First you write down a cubed, a squared, a, and then you go backwards writing b cubed, b squared, b. So this is all the a's and b combinations in a nice order, with the a's starting at the top and going down, and the b's starting at the bottom and going up, and the total power is the same in each case. Okay, it's all 3. Here we've got 3 a times a, here we've got a times b, and so on. Now we need to know what the coefficients are, and we use Pascal's triangle, of course. And this is going to be 1, 3, 3, 1. And I hope that you know that that row of Pascal's triangle is 1, 3, 3, 1, just like that. So we put in the coefficients 1, 3, 3, 1. And finally we do the signs, which go plus, minus, plus, minus, plus, minus, plus, minus. This is why it's important to have written the terms out in the correct order, with the a's going down and the b's going up, because then we can just immediately know that the signs go plus, minus, and that's absolutely the end of the story. So I hope that you can do that for the binomial theorem. Question 6 was a slightly funny one. Question 6 was e to the power of 1 minus a half. Now, quite a lot of people said, oh, well, this is e to the 1 multiplied by e to the minus half, which equals e to the 1 divided by e to the half. Now, this is true, but I don't understand why you don't just go, oh, 1 minus a half, well, that's obviously a half, so this is immediately going to be e to the power of a half. Why do you see that and suddenly decide you're going to split it up like this instead of just saying 1 minus a half is a half? I don't know. The last one I want to talk about is question 10, which was this thing with tan. If tan x equals 1, then I think that many people are deeply prone to grabbing for their calculator, typing in tan to the minus 1, and then discovering that as a decimal, x is approximately 0.785. Approximately. To 3 decimal places. But instead of immediately leaping for your calculator, have a look at what this says. Tan of x equals 1. Well, tan is the opposite over the adjacent. That's not a right angled triangle. Let's try that again. Right. So if this is x, if tan of x is going to be 1, this means that this equals this, right? So this has to be, say, some length a, and this length is also going to have to be a in order for the opposite over the adjacent to be 1. So if these two are the same length, how big is this? Well, of course, it's got to be pi by 4. Then, of course, there's the issue that this is periodic. But that wasn't really what was bothering me about this answer. What was bothering me about this answer was the fact that people are so keen to leap for their calculator and produce a decimal answer. There shouldn't be any need to produce a decimal answer if you've got e's or square roots or logs or sines and coses or whatever. Leave it as sine and cos, unless you're doing some applied course, in which case maybe you need an actual number. But in pure courses, it's more accurate. This is an accurate answer. This is an approximate answer. Which do we prefer? We prefer the accurate answer. Okay? Good. Right, that's all about question 1.